Okay, this is 7.5 homework help. The first problem wants us to look at this system of inequalities right here and match it with the region of the graph that they give us, and I made it bigger right here. So it's either A, B, C, or D. It's one of these regions that is the solution to this system of inequalities. Okay, so what I do is first determine what line is which. So if you look at this first line right here, if you plug in 0 for x, you get, and solve, you get 0 for y. That's that point right there, so that's got to be the blue line. And then the second equation obviously is the black line. So then I figure out which way to shade. So I'm going to look at the blue line first, and I'm going to pick a point not on the blue line. Like, pick an easy point, like 1, 0 is an easy point. And I'm going to plug it into the blue line. When you plug in 1, 0, you get 3 minus 0. Is that greater than or equal to 0? It is, so that means I would shade this side of the blue line. Okay. Now I'll do the same thing with the black line. Pick a number, an easy number that is on one of the other sides, like 0, 0 for example. And if I pick 0, 0 and plug it in, I get 0 is less than or equal to 6, which is true, which means that's in the solution set, so that means that I would have to shade that side of the line. The overlap then is our answer, which is region B. Okay, the next question gives us another system of inequalities here, and it asks if the region is bounded or unbounded, and then it wants the corner points. So let's draw a rough sketch of this real quick. X is greater than or equal to 2. X equals 2 is this vertical line here, and we want all the points that are greater than that, so we're going to shade to the right of it. Y is less than or equal to 14, so let's say that this is 14. That would be this solid line, and then all the points underneath it. And then we have this other line, y is greater than 2x. 2x is a line with a slope of 2 and a y-intercept of 0. These are the corner points then. X has to be greater than 0 and y has to be greater than 0. But if you shade the right sides of these lines, the inside, the shading part would be this part. And then the corner points we can find, we know this is the x value is 2, so we can plug this into the line, y equals 2x, and that gives us a y value of 4. This would be if you plug in 14, if you solve the, this system where y equals 14, you have 14 equals 2x, the intersection between those two lines, so x equals 7. And then this is obviously an x coordinate of 2 and a y coordinate of 14. So there's the corner points, and the region is bounded because it's closed in by those corner points. So just put those corner points right here. All right, the next problem just gives us an inequality, wants us to solve it, simplify it. Whenever you have fractions in an inequality or an equal sign, you can clear fractions by multiplying through by 6, so that's the easiest way. Multiply everything through by 6 here. You'd get negative 27, 3 goes into 6 twice, so that'd be negative 2x. This gives you x is less than or equal to 24x minus, and 3 goes into 6 2 times, so it'd be minus 2. So then this becomes negative x, and I can add x to both sides. It gives me 25x over here, and I can add 2 to both sides, and that gives me negative 25. Divide both sides by 25, and you get x is greater than or equal to negative 1. I know it's kind of hard to enter this in. You have to do like greater than, equal to, negative 1, like that. All right, here's another pretty easy one right from Algebra 2. Just distribute and solve, so I'll just show you each step. So here's the first step after you distribute these to both terms. Now add like terms, and you get this right here. Now add 2x to both sides, and you get 3x. Add 25 to both sides, and you get 33. Divide both sides by 3. X is greater than 11 for me. Okay, the next problem solved these, both of these, the compound inequality. So we're going to add like terms again. So I'm going to add 5 to both sides and, subtract x, or add 23 to both sides and then subtract x from both sides. And 18 is less than or equal to 3x. Divide both sides by 3, and you get x is greater than or equal to 6. Now the right side, subtract 5 from both sides, and you get 3x is greater than 6. Divide both sides by 3, you get x is greater than 2. Now, and means intersection. Okay, or means one or the other. Or technically kind of means both. And means intersection. So or means, I guess, one or the other is a better way to look at it. I know this gets a little confusing. But and means intersection. So I guess if you want to draw a picture, sometimes that helps, because if this is, say, 0, and this is 2 right here, 3, 4, 5, 6 is right here, then what these look like is x is greater than or equal to 6 is a closed circle here forever this way, and x is greater than 2 is an open circle here forever that way. Well, and is the intersection. The intersection of both of these is this part. So it's just this is my answer, greater than or equal to 6. Okay, this is a linear programming problem where you're given a constraint region, which they have graphed for us, which is nice. They even give us the corner points, so we don't have to find those. And they want us to maximize this equation right here. So we're choosing this point, so one of these points that maximize this equation. Now, obviously, it's either this point, or this point, because what maximizes this equation is, the larger x and the larger y values. So we're going to test those points, plug those points in. So, so the first is 520. The value of z would be 3 times 5 plus 4 times 20, 95. Now I'll try 1419. That's 118. And then last I'll try 1612. And that gives me 96. So obviously I'm looking at this is the point that maximizes it. The maximum value is 118 and that corner point is 419. Okay, the next problem is very similar. This is the equation we're maximizing and these are my constraints. So I'm gonna have to graph those. So let me graph the first equation first. If you plug in 0 for x, 1, so this is gonna be my x1 axis, this is gonna be my x2 axis. If you plug in 0 for x, you get 10 for y, so that's up here. And then if you plug in 0 for x2, I should say, instead of y, you get 2 for x1. So that's this equation right here. And it's a full thick line. I'm only going to graph that part of it because we need x to be greater than 0 and x2 to be greater than 0. And then the other equation, if you plug in 0 for x, again, find 2 points, you get this line here. So I obviously want to pick these 2 points then to maximize it. You have 15 comma 0 and you have 0, 3. And it's not hard to see that it's probably going to be this point up here. So 6 times 15 is probably bigger than 3 times 11. And it is. So that should be my answer if you plug in this point in for x1, x2 for p. If you do that, that gives you, and I'm sorry, this is supposed to be 0, 15. And this is supposed to be 3, 0. So then this would be my point, 0, 15 would be 11 times 15 when you plug it in, which gives you. Okay, this last problem, or this next problem, is similar to the last one where we're given an equation we need to maximize and we're given some other equations we need to graph. So the best way to graph these is by choosing 2 points. So for the first one, if you plug in 0 for x1, this would be like the x1 axis, this would be the x2 axis. When you plug in 0 for x1, you get 10 for y. So 0, 10 is up here, let's say. And then, plug in 0 for y, or x2, and you get 2 for x. So here's the first equation right there. Next equation then is similar, where if you plug in 0 for x, you get 3. So let's say that's here. And then if you plug in 0 for x2, right here, you get 15. So that'd be out to here. So there's my constraint equations. X has to be bigger than 0, y has to be bigger than 0. Here's my region that I'm talking about. The region, if I were to shade it, would look like this. I can try some points just to make sure. When you plug in 0, 0, it satisfies this one. And when you plug in 0, 0, it satisfies that one as well. So I'm shading below both those 2 lines because 0, 0 is a solution to both of them. So then I'm looking at this constraint region. So my answers are going to be the intersection point there, this point, which is 0, 3, or this point, which is 2, 0. Those are going to be my options. The intersection between these 2 lines, I have to solve that system. So if you use like elimination by multiplying one of them by -5, for example, you get about 1.46 and 1.37. I'm going to keep those numbers not rounded in my calculator because that's the corner point that's going to be important for me to check if it maximizes this. So first, if I plug in 0, 3, that'd be 33 for p. And now the point 2, 0, if I plug that in, gives me 12. And then if you plug in this point here, that should give me, actually this number should have been 2.71 right there. And when I plug that into this equation, 6 times 1.46 plus 11 times 2.71, that's the maximum, 38.6. 0.54. Okay, the next problem wants me to graph this, so I'm going to go ahead and graph this system really quickly. Okay, now assuming I've graphed these lines right, these two diagonal lines are the hardest ones. The rest of them are pretty easy to graph, and so I'm looking for these corner points right here. So I need to find these intersection points. This one's pretty easy to find because this line that's the x-coordinate of 7, because that's x equals 7, and the y-coordinate's 5 there. And this x-coordinate's negative 5. So those are easy. Then you got to find the intersection. So like for example, this was x equals 7, so I got to plug in 7 into this blue line, which is the first line I did. 7 goes in for x. That gives me about negative 0.18. I better do like one more decimal place to make sure for Webwork. 3. Now next, this intersection of these two lines, I'm going to have to solve this system right here. I get negative 2, negative 3. Those numbers worked out all right. And the last point is this intersection point right here, which the x value is obviously negative 5, and I need to plug it back into the black line, which is this one right here. And y equals negative 1 at that point. So there's my points. Now it wants me to list the vertices, starting with the vertex's y-coordinate is the lowest. That'd be this point down here. So that'd be negative 2, negative 3. And then it wants me to go clockwise. So the rest of them are here. And this last number for me should have been negative 1. I don't know what I was thinking, but when I plugged 7 into this equation for this line right here, this should have been negative 1. Okay, the next problem, we're just choosing 3 inequalities that form this green triangle. So just choose 3 of these. Now obviously y has to be bigger than negative 4. So we're looking for that. Y is greater than or equal to negative 4, which is this one right here. It's an easy one. That's this line, shading above it. Now we need to choose the other two lines here. So what I like to do is, like for this line, for example, I notice the slope is up 7 over 3. So I like to write it in y equals mx plus b form. Y equals mx plus b, the y-intercept's 3. And then choose the inequality. So pick a test point if you want, like 0, 0, but 0, 0 should solve the inequality, which it does. So my inequality is less than or equal to. And then, I clear fractions by multiplying through by 3. It's moving the 7 over, multiplying through by 1 is the last step in order to get the first term positive, which is what all the equations that they had were. And this is my equation, which would be, it looks like f. And then there's just one more, and that's this line here. So I'm going to do the same exact thing. So here's my first inequality. Then once again, multiply through by 3. And then add 7x to both sides. And that equation right is E. And the last problem, when you graph the two lines, the black, here's the red one, here's the black one. And that's a quadrilateral, obviously. And then it wants the vertices, so 0, 0. Once it says proceed clockwise from the first vertex, the smallest x value and the smallest y value. So that'd be 0, 0. And then if we're going to go clockwise, the next one would be 0, 5. The next one would be this intersection point. The last one would be 2.25, comma 0. This one's the hard one because you have to solve this system right there. So I'm going to multiply through by negative 1, and I get negative x plus negative y is equal to negative 5. Use equal signs here. Then you have 4x plus y is equal to 9, and when you add those equations together, you get 3x is equal to 4. So 4/3 is the x-coordinate. And then plug that back into one of these to find the y-coordinate, and you get 3.6 repeating, and that should work.